In this video, we are going to practice finding the derivative of a function using the chain rule. Now, in order for me to do this, I must first make sure that I can write my function as a power function. In other words, instead of writing this function as the square root of 3x minus 4, I'm going to change that root to an exponent of a half. So in other words, I've got 3x minus 4 all to the half. I'm also going to identify in my original function what is the f of x function and what is the g of x function. So the f of x in this function is going to be my outer function. In other words, that's going to be x to the half. And then my g of x function is my inner function. And that function is going to be the function of 3x minus 4. If I want to find my derivative of this function, then I must find the derivative of the outer function, and I times that answer by the derivative of the inner function. So dy by dx must be the derivative of f of x. Remember, when I find the derivative of f of x, I treat the inner function 3x minus 4 as the x. In other words, I'm going to have a half 3x minus 4, and then a half minus 1 is in fact minus a half. Now I need to times this answer by the derivative of the inner function, and the derivative of 3x minus 4 is 3. When we do these sums, it's nice sometimes to make it so that it looks nice and neat, but that is a perfect answer. I'm going to now simplify the derivative, but please don't do this unless you are specifically asked to do so. So if I write this derivative so that I have positive exponents and all my coefficients are together, this derivative is going to be a half times 3, which is 3 all over 2. And then if I take 3x minus 4 to the minus a half and I write it with a positive exponent, it must be written in the denominator of my fraction. In other words, it could be written as follows. Now you know that because we changed our square root to have a power of a half, I could change it back again. So the final step in simplifying this derivative is to change 3x minus 4 to the half so that it is written as the square root of 3x minus 4. But remember, the first step in the derivative, a half times by 3x minus 4 to the minus a half times by 3, is in fact a perfect answer. It's just not a simplified answer. Now you would have noticed when I used the chain rule that I still had my information in the numerator. So if I want to find the derivative of this function called f of x, then I must make sure that I write that information, which is given by the bracket of 6x minus 1 to the 4 in the denominator, in the numerator of my fraction. As my numerator was just 1, I can take that factor up, and the factor is going to be to the minus 4 in the numerator. I can now identify very nicely my outer function and my inner function of f of x. If I highlight the inner function, you can see that the outer function for this is going to be x to the minus 4. The inner function is going to be 6x minus 1. So now finding the derivative of f of x, the derivative of the outer function is going to be minus 4 times by x to the minus 4 minus 1, which is minus 5. And now I times that by the derivative of the inner function, and the derivative of 6x minus 1 is 6. Once again, this is a perfect answer, but if I simplify this, the derivative of this function is going to be minus 24 all over 6x minus 1 to the 5. In example 3, I want you to find the derivative of the composite function, but I have not yet combined those functions. So if I want the derivative of g of f of x, I actually want to find the derivative of the function g of f of x. In other words, I want to, on the g function, put in the f function where the x is. In other words, I need to replace the x with 3x minus 1. So g of f of x is actually going to be the cubed root of 3x minus 1. Now remember, if I want to find the derivative of a function, I want to write it as a power function. So I'm going to now change the cubed root so that my function is to the third. So g of f of x, the function that I want to find the derivative of, is 3x minus 1 all to the third. You can now very nicely see your inner and your outer function. When I find the derivative of a composite function, I must find the derivative of the outer function and times it by the derivative of the inner function. So the derivative in in the variable x of g of f of x is given to me by the derivative of the outer function is going to be a third 3x minus 1, and then a third minus 1 is minus 2/3, and the derivative of the inner function is 3. Remember, I told you that this is a perfect answer, but for the sake of practicing simplification, that's what we're going to do in this next step. I'm going to do the simplifying in 2 steps. So the derivative of g of f of x is going to be a third times 3 is 1. So in my numerator, I've got just a 1. If I write the bracket factor so that it has a positive exponent, in my denominator, I've now got 3x minus 1 to the 2 all over 3. Well, that means that I've got 3x minus 2 squared cube rooted. So lastly, if I want to simplify this still a little bit further, then I could have written it as follows. The cubed root of 3x minus 1 all squared.